let's do a physics problem. I actually gave this one in class. And I saw a problem. This is the beginning of the semester, so the problem's not a big deal. They're going to fix their problems. But here's the question. So you have a ball launched towards a wall from the ground. And the question is, where on the wall does it hit? How high up on the wall does it hit? Now, the problem is that a lot of students just said, okay, I know the velocity, I know the launch angle, so I can use some type of trig and right triangle to find out where it goes. But balls don't go that way. They're not going to go in a straight line, right? They're going to curve. And so we need to do a little bit of work to find out where that is. So the first thing that we want to do is to break this into an x problem and a y problem. We have two one-dimensional problems that we put together. Okay, so in the x problem, we need the x velocity. So if I know the launch velocity of 8 meters per second at an angle of 60 degrees, in this case, because I'm measuring the angle from the x-axis, I can use cosine to find the x velocity and sine to find the y velocity. Okay, got that. Now I have two kinematic equations. I have one for the x direction with 0 acceleration. It doesn't accelerate in the x direction. And then one in the y direction with an acceleration of negative g. So you have those two kinematic equations. Those two kinematic equations have the same time. Whatever the motion takes in the horizontal axis is the same as the vertical axis. So if you can solve the time for one of those situations, you can use it in the other situation. Well, in this case, we can use the x to solve for time because I know the final x is 3 meters, the initial x is 0, and I know the x velocity. That gives me a time of 0.75 seconds. Now I can plug that in here and find the final y. It's pretty easy after that, and I get 2.44 meters. Physics.